So I did write something down. I don't like. Yeah, it's just kind of on everything. I did write something down. I can't get through any public talk. I get so distracted. I go down rabbit holes, and I never get my message across. So I'm going to do 3 things on this talk. I'm going to tell you a little bit about myself. I'm going to tell you a little bit about my management style, or management styles in general, and I'm probably going to finish with what interests me about Atomist. I think that's all I can do. So I'm going to be quick as well, because I don't know how much time I've got. So my background, I'm not a Java guy at all. And in my communities, I've got like a very strong C# community and a very strong Java community. My background is C++ and C#. And I spent 15 years in high-frequency trading and algo trading, messing around with hardware stuff like FPGA. And I'm still a developer at heart, I guess. And I really enjoy. I actually just came this evening from the Reserve Bank, where APSA did a distributed ledger transaction with Standard Bank for 10 million rand on an RTGS switch using something called Quorum. I'm just going to give you the words, you can Google them afterwards. Patterson commit, that's quite crazy, and Whisper was the protocol. And we did it in front of about 300 or 400 banks, and I think most of the audience saw web pages with numbers going across, and in their head they're thinking SQL Server. Right, so that's fine, you know. But I'm an avid technologist. I always pick something each year. Right now, I'm playing around a lot with mmap. I really enjoy that. I'm playing around with libuv as well. I don't know, you guys must know that as well. I really like the single-threaded event dispatching mechanism there. It's very, very, very high throughput. I like Spark and Kafka, but my roots are still not Java. So I'm going to explain to you why I'm so passionate about something that I understand so little, even though the semicolon, I guess, is common to the world that I know. And it's quite simple. In management, there are two things, actually. There are 2 types of managers, fundamentally. You might not know this, in fact, I know you don't know this, but I was a DJ for quite a few years, and there's a good reason for that. I can't dance at all. I'm useless at it. And so why would you do that? Well, when you look around, there's people doing all these seductive moves and very creative things. And in management, it's quite similar, right? There are two characteristics. If you look at management consultants, they come to you with beautiful PowerPoint, they make all these moves, but nothing really happens. And on the flip side of it, you have you guys, right? And I don't want to disrespect you or anything. You are beautiful, right? But you don't come across that well at an exco level, and you don't have the right content, the right way to deliver that. And what's really powerful is that you only do 2 things. You make those moves or you execute. And what really struck me, the first big project I ever did on open source, was the speed of the execution. So in my mind, when I looked, we did something called DebiCheck. I don't know if you guys have heard of that. It was an interbank protocol. Everyone in South Africa pretty much picked mainframe for that. And Donovan and Derek in APSA picked the open source PaaS approach. And we delivered it on time. It was something really special. It was a really nice piece of technology. And the start of the project was awful. It was a little bit clumsy. It didn't quite work. The environment didn't get out. The PowerPoint for it didn't really support it. The audience around, I don't think you really got proper buy-in. But at the end of that, something got created, and it was really, really magical. And that's spread across the whole of the organization now. They have a stack in the organization, and it even has PowerPoint now. It even has awesome, beautiful PowerPoint. Okay. But there was a problem. As it spread, we started to realize that we moved into a new paradigm where teams that were fundamentally tooled like I was, I guess 5 years ago, couldn't repeat the success that they had easily. And so every project that I went through, and I was selling this PaaS thing, and I was saying, hey, you know what? We can set up an environment in minutes. I work in a bank. The fact that we had to put certificates on the CI/CD pipeline, the fact that we had all these SOX controls in place, meant that this thing that we sold, this dance, this kind of PowerPoint we sold, actually didn't exist in real life. And the guys were 6 weeks in, and there was the patching of the environments, and pretty much everything we did was not repeatable. It wasn't repeatable. It should have been repeatable. And I had a conversation with them in end of last year, probably October, November. I said, no, I'm not backing away from this. This is an awesome, you guys have done miracles, but I can't scale it to 4,000 people. And so I got a demo about, I think it was about 2 months ago, where they stood up in front of me and they created an environment in minutes on Slack, and it was a dance. It looked beautiful, and there was no PowerPoint involved. And I tweeted it, and I unashamedly, and I didn't quite get how they'd done what they'd done, but it was the first time I'd ever seen something that really felt like we could create highly productive developers in the business, delivering value for the business, no central function, no talk of economies of scales, completely federated DevOps deliveries, but with all the standards and the repeatability that we were never quite able, we could achieve it through people if they could remember what they did last time. And this was the first time I'd seen something that wasn't just creating a server or creating a database. It actually created a whole environment to a certain standard. So they invited the Atomist guys here tonight. I don't know what you guys know about this, but when I saw the demo, I was blown away. I'm going to hand over to them. Yeah, and a big round of applause for the Atomist guys.
Oh, do I actually need this? I mean, this is not loud speaking, right? Can you guys hear me okay? I can't really code and hold this up here. So let me just put that aside. And so I think first things first, thanks for AppSA for first of all sponsoring this evening. Thanks for the local Java user group to inviting us and kind of making this evening possible. I have Rick here with me, he's kind of our account manager, and my name is Christian Dupuis. I'm a member of the founding team at Atomist. I work alongside a guy called Rod Johnson. So we are here at the Java user group. So many of you may know his name. He's the creator of Spring. He's kind of the leading character when it comes to change in the Java EE ecosystem as we see it today. And Atomist is kind of the first company after Rod and kind of all the Spring Source people sold the company to VMware. We went through the pivotal spin-off. And subsequently, kind of Rod decided to come really engaged in this developer productivity market again. Again, I was an early member of the Spring team, so I know a lot about Spring Framework. We used to work alongside Rod and Jürgen Höller and all the other famous guys in the Spring ecosystem. Created my own little Spring project called Spring IDE, and then Spring Source Tool Suite, and all these things that you may have seen in when working with Spring. I also was involved in the early days creating Spring Boot and some of these things that still exist today. So, and you can ask me all sorts of questions. What do you want to know about these things? But I'm actually today here not to talk much about Java. You'll see a little bit of Spring and how we use Spring as a sample application, or how we create Spring applications as a sample and kind of push this all the way to a development environment or production environment running on top of Kubernetes. So, taking a step back, Atomist is about developer automation. So think about Atomist as a platform that allows you to automate your entire day and your delivery of your software. So you can, more than things that you can normally put into a CI/CD pipeline that is just purely centered around your code, your binary artifacts, pushing something to an Artifactory or to a Kubernetes cluster. With Atomist, you can automate pretty much everything that you can think of. Things like your policies around commit messages, how they need to be formatted. Things like when someone raises an issue with a missing body, you get it an event that you can send a message to the guy saying, you know what, you don't follow our standards here. But then you can also do things like really going in and doing deep delivery aspects and really delivering software, doing binary builds, pushing things to a Docker repository, deploying things to Kubernetes, and so on and so forth. So since I'm very sure that most of you haven't really heard about Atomist, I want to give you guys a very high-level demo and then try to go into the details a little bit more as we talk about how these things are actually working and what does it mean to be an event-driven automation platform. So let me do one thing first. I've been told that I should record this using screen sharing. So let me do this. I'm not starting my video, but I have to unmute and press the record button here, and then I share my screen. And then let me go back to the slides. There are, as you can see, 4 slides. So a lot of code and a lot of demo. And again, I really like to get questions while we talk, not at the end. So if you see anything that's not clear, and if you want to dive deeper, please feel free to ask me these questions when you kind of feel like I want to ask these questions. So first of all, and I think a lot of what Andrew said is really where we're coming in. So that's where we're really strong. Everyone's wanting to move to cloud native, do things very agile, deploying 100 times a day, and so on, all these buzzwords, right? And I'm sure all of you guys see this every day in your job. Cloud native, more services, you have to deliver more and more things consistently, and that's really a challenge. With traditional CI/CD tools, you're managing your CI pipelines on a per repo, on a per service basis, and that really leads to inconsistencies as you ramp up the number of services. So you have to constantly manage and go back and manage those CI pipelines, and no one really enjoys that, writing shell scripts and YAML files. That's not what we are. We are software engineers. We want to write software, not shell scripts. And at least that's and many of my colleagues agree there. And definitely Rod, right? Rod does not like shell scripts. So it's all about code. You want to write code, you want to write tests. And this is what we think your automation should be written in proper code that lives on GitHub, that has a release process. You create tags, you create Docker images, you publish that something, and that becomes your delivery process. So what we want to do is help you realize your delivery blueprint. So that's, again, lots of buzzwords here, but really think about Atomist as a platform that allows you to do whatever you have in mind, how your delivery process should look like, from the code, from someone creating a Jira issue, all the way to your production deployment. And further, if something happens in your production environment, like an APM alert comes in, New Relic, Sentry, all these things, you can bring them back in and close the loop and really use the full power of Atomist here. So how do we achieve this? In the middle, there's our little Atomist logo. At the top, we see the usual front end. So Andrew mentioned ChatOps is really big for us. So we are really most of our things are really good in Slack. And I show you a lot of what our Slack interface looks like. We have a web console, a dashboard, which is being actively developed, and that gives you the same abilities that you can do in Slack, minus the collaboration aspect. So really, Slack really empowers your team to work on something together, which is what you don't really get when you work off of the web console. And then there's GraphQL, and I'm going to come back to this later. At the bottom, you see a little bit of an example of all the tools that you can integrate with Atomist. Some of them come natively if you just install or start using us, for example, GitHub, Bitbucket. These are things that we just support out of the box. And then as we move to the right, there's source code analysis, Black Duck, SonarQube, continuous integration, Jenkins, Travis. You see all these logos up there. What it really means is all of these things, believe it or not, send events. They emit events along the software lifecycle, along the process as you push your code through your pipeline. There's a GitHub push here, a Black Duck security violation, a Jenkins build has started, has failed. A Docker image has been pushed to the Docker registry. A Docker image has been published or started in a Kubernetes cluster. Sentry, New Relic, they send alerts. And all of these things get sent to Atomist, and we correlate these things together and build up a graph database of these things. So that's what you see on the top right there. We exposed the graph database in something really nice, which is called GraphQL. So if you guys looked at JavaScript front-end technologies, React, you probably have seen GraphQL. Most of the backend developers aren't really familiar with GraphQL. It's a graph query language. So really powerful. You effectively define the shape of your data as you navigate the graph of what data you want the query to return. Interestingly, GraphQL has the notion of subscriptions. So not only can you query the database, but you can also subscribe to events. So think about, let's start at the back. There's an APM alert coming from Sentry. normally what would happen is like you would receive the event, and then you as a developer need to hunt down all the correlated information. What's the commit? What's the environment this is running in? What's the version that this software that currently raised the event is currently at? Who was the last person who committed that? What's the person's Slack identity? And now you send him a message. So like a lot of manual to-dos here. With Atomist, this is really a GraphQL query across the graph. So you subscribe to the Sentry event, and then you navigate the graph all the way to the person's Slack identity of like, go back from the person in Slack, in GitHub, Bitbucket, the author of the commit that got deployed in your Kubernetes cluster, and that's the version currently raising the Sentry alert. So this is how you need to think about Atomist. We correlate all this information together and become this kind of source of truth of like what's happening in your system.
So do you link my corporate identity with my Slack identity?
Yes, we do. So we kind of link across all these things. And interestingly, what I didn't mention on the right side there, certainly we don't support everything that's on the market, right? You have internal systems around corporate toll gates, corporate requirements management tools. These sit on the right side. So you can define your own types that get ingested into our model. You can define your own correlations, how you want to correlate these things into the graph so that they show up as part of the graph, and you can construct one correlated query across these things. Let's talk a little bit about architecture and what it means to like use Atomist. And I've spent an awful lot of time talking about like the layer above there. Like the database is what we call the Atomist cortex. It's one of our marketing terms around it. This is the brain of Atomist. This is where we collect all the information. It's exposed via GraphQL to like these front-end tools. So you can run GraphQL queries against the data and just create simple dashboards for your reporting purposes if you really want to. It's not what we do. Again, we are more a platform to enable you to do things. Then there is Slack, and there is code, which means you can invoke things that kind of run underneath in the automation engine via like REST calls, a REST API, curl, and whatnot. So let's talk a little bit about this automation engine. This is really where you come in as a developer. Like, so what we've been working with Donovan and his team around like automating some of their environments and like stuff that Andrew mentioned earlier. This is something that you write as a developer. You spin up event handlers and command handlers. Like event handlers subscribe to events in the cortex. Command handlers are things that you can invoke via code, via Slack, or via the web. So that are things that like a human or a machine can kind of trigger. And these event and command handlers are really they are really running inside your network, inside your data center. So this thing here is something that you make your own. Most of our things are open source, so you can take all of this and run it on-prem, not exposing any secrets to us, not exposing any APIs to us. What this thing does, it is effectively, when you start it up, it registers with us, with our API, and establishes an outgoing WebSocket connection. So every time someone triggers a Slack command, your client running in your data center gets a callback. Every time there's an event happening from one of your systems, you get a callback into your client running in your data center. And you can have multiple of those. You can scale them horizontally as you wish. They can run clustered, they can run sharded, whatever you feel like. And we tend to take these things, wrap them in a Docker image, and deploy them in a Kubernetes cluster. And then these are ultimately the things that call APIs against these systems. Not Atomist, really. We provide you a lot of these functionalities that you can run, but really, ultimately, this code is yours to write. So let's take a look at how this feels from just a user perspective in Slack. Let's just try to. All right, so this is one of our Slack teams here, and I just cleaned up so that you don't see all the histories because I've been doing this demo quite a few times. Let me get rid of this window here. So one of the things that you can do with Atomist is you have this little Atomist app, the bot running in your environment. This is kind of like our Slack interface, and you can tell the bot, not that, bot doesn't know about, but it knows about create Spring. So what this does is it's a so-called, like create Spring is an intent registered by one of our command handlers, again, that I wrote. You can write the same thing, that starting to collect a bunch of parameters and then it's triggering some action. And I'm going to show you the code, how this looks like from a code perspective in a little bit. So now I'm going to go through the parameter acquisition. It's asking me about like, what should my new repository be named? And since this is a Java project, it's com.atomist. And now you see kind of like the bot has asked me all the required parameters. All the others are kind of optional. There are things like version number, Maven group ID, what else? If you want to install a webhook and so on and so forth. You can change kind of like the visibility of the repository that's being created. So most of the enterprises would like that to be private. For our demos, we mostly do public. And then you could just say submit. You can type submit, or you can just press the button. And now what happens is, with Atomist, we have the concept of a seed project. So this is like where your own kind of like policies kick in. A seed project is a living project on GitHub. And let me navigate there to show you this is really a living Spring Boot application.
The commands, are all sort of keyword based, or is there any NLP behind the scenes?
That's a good question. So the question was, is there any NLP support for these commands? And surprisingly, we had NLP in the beginning. None of our developers internally and also like early customers liked that. They really wanted to have more like a CLI interface. Like they wanted to exactly know what are the commands that I can invoke and not have the bot guess. So we still have the code, but we haven't had the use case to actually enable it yet. So yeah, your answer is yes, we have it, but no one's really want to use that so far. All right, so this is our seed project here. And the thing that I want to show you, this is really just, I could clone this and bring it into my Eclipse and run it. This is a working application. So this is where you put your best practices in, where you could like, let's say, in your company, we always create projects that way. That's my blueprint. And it can be a living application. You could even point it at one that you already have deployed in production. And you see there are the package names and all of these things, they're completely like, there aren't any variables in here, and you could take a look at this. This is all open source. There's no magic in this. So for this particular thing, for the demo later, I added like our best practice that all our applications should use the Sentry monitoring agents. So there is some basic monitoring in this app, and when I deploy it, I get this monitoring, and I'll get back to this later. So now, what the bot did here effectively, it created a new repository I called CD07 in the GitHub organization that's connected to this Atomist workspace. And you can have multiple GitHub organizations. You can have Bitbucket, GHE, Bitbucket Cloud, all of these things connected to an Atomist workspace. And now let's take a look what happened. Like the README obviously got renamed, as you would expect. Things like the package name. So it used to be com.atomist.play, and now it's com.atomist, and the class names are now CD07. You can go in there. And again, this is just code that really works. There's no magic here. What we did is, in our command handler, we have a little AST language that really understands your source code. And if you tell us, again, this is your code, your automation, if you want to rewrite your package names across the whole source code, if you want to put license headers in. All of this stuff is really ready for you to do based on an AST. Much like if you do an Eclipse refactoring or like an IntelliJ refactoring, it's more or less the same technology embedded in an automation that you can run. So this is what happened here. We actually effectively rewrote the entire AST when I said create Spring. Let's go back. The other thing that happened here, and I don't know if you noticed that, there's this create 07 project. So the bot asked me to, do you want to put me to work on this repository? Which means we noticed that there was a new repo created. Again, event-driven. So there was an event, and the bot's now, one of our best practices again, is asking me to create a channel. Creating a channel means we are linking the GitHub repository to a channel. So this concept is something that exists, linking channels together and kind of create a context here in which you can discuss certain services. I pressed this button, and as you would expect, there's now a channel here. And just trying to hide a couple of things here before I show everything. You now see that this guy joined the channel. This is one of our engineers. He's the one who authored the bot to join Slack. The bot himself joined, and I joined the channel. And again, there's this little message here. Our best practice at Atomist is that every Spring Boot project for this demo should have a Docker file because we want to deploy it to Kubernetes. So this event here, this new repo event that was captured by the platform, by one of your event handlers that you could write, noticed that repository does not have a Docker file. So I could just press the button and add the Docker file. I'll do this in a second. There's another thing here called like the channel linking, which is effectively what I mentioned earlier. You can link channels, you can link multiple repositories to one channel, you can link a repository to multiple channels. So you could create these groupings as you wish. You could link branches to channels. So if you work on feature branches across several repositories, just create these linkings as you wish. And then you did see something like this here, which is effectively our commit message at the very top. That's not very exciting. That's just a commit message that the GitHub integration gives you too. But you see the green dot on the right? This is your CI build that automatically kicked in without doing much. It just happened because Atomist, the automation platform, set all these things up for you. The build is correlated to this commit, so it's in line with the message. And as this build happens, we rewrite the message. So you never get like this fire hose of events in your Slack channel that no one likes to be in. You get one concise message, commit, there's a build, and the build was successful. You can click on it, that opens up the build log, goes to Travis, goes to Jenkins, whatever CI systems you're integrating. And then here are something like what we call goals. And this is where another concept of Atomist comes in, which is something that we built on top of the core platform. On top of command and event handlers, we built something called a software delivery machine. And that software delivery machine is really, you need to think about this as a CI/CD pipeline, but it can span like issue creation all the way to production and like APM and back. So a little bit more than Jenkins pipeline can do you. You see, we scheduled goals. Goals are usually steps in a pipeline. Auto-fixed, code reviewed, we versioned the project, we kind of build it, we tagged it. Here are the tags. Again, all inline, correlated in the graph, and visually represented for you. You can press this button that creates a GitHub release, and we publish the artifact to Artifactory. All of these things, you can click these links, and they open up like specific log files for this particular thing. What I want to show you, like, just keep in mind that this goal set, or some people say pipeline, is named build. Because now that we go through the demo, I want to show you one important aspect. So let me click this button here, add Docker file. And now, did I press it? Yeah. Here we go. So again, as you would expect, or not, I mean, this can sometimes be a bit magical. There's a commit now on a branch that, believe it or not, there may be a pull request, or maybe not. That really depends on what you like. But this build is currently happening, so something obviously is kicking in. Let's take a look at what it did. Again, applied best practices. This is how we want our Docker file to look like. Don't watch too closely. I know everyone wants to do Spring Boot Docker files differently. This is just a way we do it, and it works. We also do like a Docker ignore, and we give you like this pull request on a branch. And there are different modes too. So you, for example, some people don't like the pull request right away. You want your CI builds to pass first, and then you want to raise the pull request if they actually passed. So this is possible too. And for this demo to just speed things up, we kind of like didn't do this. So let's go back to Slack and take a look here. What do we see here? Again, our goals get scheduled, and you see kind of like how the pipeline updates itself. And you also see that this is now Docker build. So without changing anything, it's event-driven. It has a software delivery machine connected to this team. The thing noticed that there's now a Docker file, so I want to schedule different goals because I want to execute a different pipeline, which now includes a Docker build. So there's now a Docker build running that will lead into like a published Docker image that gets published to a Docker registry. All like you can configure all of these things, like where you want to publish this to. In fact, you can write this own code. Like you can write your own goal implementations. And then at the end, it will be tagged. The other interesting thing here, just the correlation aspect again, there's your pull request. Again, inlined in the message. So if you have lots of stuff happening in that channel, people are having conversations, you never really lose track of what's going on with this particular commit. Again, this rendering here that you see, and I'm just trying to like fill the gap between this Docker build being done and all this rendering is open source. So if you don't like the colors or you don't like certain things or buttons that you see there, just like clone the repo, fork it, and change it. I mean, that's what I think Donovan is planning to do with some of these messages for internal consumption, because not everyone likes our standard. But try this with like some other integrations. I mean, you're kind of lost doing that. So now here's our pull request. And you notice that there's a merge button, and I should have pointed that out earlier. That merge button wasn't there until the build was successful. So now I can merge this. And watch again, like what's going to happen now. This build pipeline used to be called Docker build. Yeah, and I messed up the demo, sorry. So one of the safeguards that I always keep forgetting when doing the demo is that we don't automatically deploy because we kind of fear that someone, or not really fear, but we want to be cautious that someone who's picking this up in open source doesn't end up publishing private repositories to like public cloud infrastructure. So there's one safeguard in there that you do enable deploy. And I should have already done this before merging the PI, because now we just have to wait one more run. But I can jump back and show you a little bit of the code that's actually like running this, which I think, especially for developers, is more interesting. So let's do this. Let's start by looking at some code. So first of all, this is all, surprise, surprise, it's TypeScript. So sorry for that not being Java. We have a Java binding too, but we found that JavaScript and TypeScript are really powerful tools to write these automations. You'll find an NPM module for almost every API out there. You probably find 10 NPM modules and need to find the one that actually works. But it's still, these things exist. So it's very easy for you to get started to be, and the other thing that I really personally like about it, running shell scripts, which is still a thing, even with Atomist. It's easy with Node, like it's single-threaded, but fear not, it has like non-blocking I/O, really, really useful in that context. So what happens here? Like an Atomist automation is really, it all starts with a file called Atomist Config TS, and that's the place where you configure the thing, pretty much like a Spring Boot application like configuration class, right? You see a lot of similarities there because lots of the same people worked on this. You have a configuration there, and in this, we just register a configure STM method. And that takes a pointer to a function called machine, which creates a software delivery machine. And here's where you start declaring your goals. So instead of having pipeline definitions in each repo, you have this one central place in where you define, like, for what pushes to what particular repositories do I want to schedule which goals. So you have to read this from the top down. So the first the first push rule that matches is the one that schedules the goals. So let's take a look at what we did first. It was Maven. It is a Maven project, and it didn't have a Docker file in the beginning. So we were just scheduling the build goals, and I'll dive into what the build goals are. The other thing that I want to point out, this is Maven thing here. And this is where we see some JavaScript now. Let me make this bigger. Since this is now compiled TypeScript, this is just code checking if a POM file exists in your project. So you get passed in a project, you have an API there that allows you to kind of check if a file exists, read the file, do modifications, all the things. Like, you have an API for all of these things. So let's go back. Let's take a look at other things. So these things are called push tests. So you write your own push tests. And now at the very end, we had Maven, we had a Spring Boot application class. That's an interesting one. Let's take a look at these things. So we are actually looking at the files, trying to find like, trying to find something that has a kind of like a certain project structure. So there is, again, the AST understanding, the semantical understanding of your projects. It's up there encapsulated in the Spring Boot project structure. It has a Docker file. It is to a public repository. It's not from Atomist, meaning we didn't do the commit. Oops. And then we're going to do the Docker goals. And now the next thing that I unfortunately screwed up a little bit is the deployment. So we have a Docker file, it's Maven, default branch, yada, yada, yada. And at the end is deploy enabled. And that's the thing that I missed. So now when we go back into Slack, we should see the deployment have happened. The other interesting concept, which unfortunately makes demoing this a little bit harder, is this material change to a JVM repo. I don't know how often you guys wait for a build to finish where someone changed the README. Not so with Atomist. We kind of like let you decide. With the push rule, you could kind of, what things actually got changed in this commit, in this change set? Does it actually make sense to push this through like a full pipeline? Does it make sense to wake up the QA people, the deployment people, because someone changed the README, right? So this is like going to stop very early on and just schedule no goals. So you're just changing the README. No, we're not going to do anything with this. Let's go back to Slack. And we now have to do a commit. So let's go into master here. And again, now I need to change a Java file and not just a README, because that wouldn't work. And for this demo, we actually don't look at the Java structure, but you could do the same. There's a concept of fingerprinting. So you can calculate a fingerprint on every resource, and that would notice that a white space change in Java doesn't really mean anything. But for this demo, again, we didn't do this. And now, surprise, surprise, since we have enabled deployment now, the pipeline or the goal set is suddenly named deploy. And at the end of the day, this will deploy to our Kubernetes cluster that we have connected to this environment. While we wait for this, I want to show you some more code. So one of the things that people tend to ask me after this demo, like, how do I get started? What is a base command handler that I could do? And one of the things that I usually show there is like a little bit like the ChatOps thing about Atomist. So Atomist create issue title some super important issue. So I can create an issue here, and that's a command handler. There's a command handler with the intent create issue, and it takes a parameter title. It also takes many more optional parameters that you can send via Slack. And so there are two things here. That's the command handler invocation, and that's an event handler that kicks in because there was a new issue event being raised, and that issue event handler renders this nice little Slack message, referencing a lot more command handlers here. So there you can put a comment in, you can put a thumbs up, close, and do all sorts of interesting things. And again, this is all extensible. We have a certain way of working. Other people, they don't like the thumbs up, so just remove it and put other things there. Some other important aspects, and we had this question earlier, how do you map identity? So usually the Slack usernames are different to your GitHub identity. Unfortunately, I'm trying very hard to get this, but it's not working out. So some important oops. So there's this guy, and you saw his name already, David Dooling, in this team. So I'm just going to ping him, and I update the, come on, update. Someone told me this Wi-Fi is being really stable. There we go. So yeah. So in this GitHub interface, it's DD genome. Like, you can probably make a guess what happens when you go to Slack here. It's David Dooling. It's a different identity. We kind of look at these things and kind of rewrite kind of like the issue text and like do these mappings for you. So you get like, and you can create issues with @mention a Slack username, and that gets translated to the GitHub username on the way out. And you can do this with all different identities that you manage across your enterprise. The other thing that you noticed, we didn't just send a new message to this channel. We actually went in and rewrote the other one. The same happens when I just close this. It'll be the same thing. So now, I actually didn't get to show you the code for this. I'll get back to this in a bit. Here's our deployment. So finally, the thing deployed to our Kubernetes cluster. So in this particular case, we're using one cluster with like 3 different namespaces: testing namespace, production namespace, and a third namespace that runs the CI pipeline. And I'll show you a little bit more about this in a bit. But just so you see, like, we deployed it. just by the simple fact there was a Docker file and enabled the deployment. No one actually put any CI configuration in the repo itself. It's all encapsulated in the single software delivery machine, in the single daemon that you can deploy into your enterprise. There's also the concept of pausing goals on certain things. So sometimes this is a bit misleading. What you really do here is you approve the deployment that happened to your testing namespace, so you verify that that actually worked. And with that, you kind of trigger the next goals. And let me just do this. Yeah. And now, another interesting aspect, we have an audit trail of all the activities that people do in Slack, inside the web interface, from the API. It knows that I, CD, approved this goal so that I want to continue the pipeline, which is really important for some of our regulated customers, that they really need a consistent audit trail where all these things get recorded. And it went through the whole thing. It's deployed to like our production namespace now. It created a GitHub release. And look down here. Here are the running Docker containers from your Kubernetes environment. So again, we received the event that this container is now running. We know which commit char that was, and we kind of can present it to you in this form. There is this services section out there. That's a daemon running inside the application, sending us events. So in case you deploy this to something that we don't understand, or your infrastructure guys have issues with deploying this little Kubernetes event listener into the kube cluster, we can still like help you with a lot of insightful information here. Now let's go back to what I said earlier. Let's take a look at how this command handler actually works and how this looks like. And for this, I go to another open source automation that we have and bring up something called create GitHub issue. So this is a command handler written in TypeScript, and I hope you can read this. Let me make this a bit bigger. So you implement an interface, export class, some class name, implements handle command. That's the interface that you have to implement. And then you can put, in the good old Spring way, or Java way, you put, in TypeScript, these are called decorators. In Java, they would be annotations. Command handler, you give your command handler a description, which shows up in the help on the dashboard, and you can register intents. These are optional. If you want command handlers to only live behind buttons or be invocable via the API, you can hide them. But this is how you register intents, create issue, create GitHub issue. And then the next thing of importance is like the parameter. So you declare a parameter. It's a field that gets the title injected when it gets invoked. You can certainly have descriptions there, validator patterns, required, true, false, and all these things that you would expect. Scrolling further down, there are things like map parameters, which is really like the contextual information of where you invoke this from. So you linked a channel to a repository. That's enough for the kind of our infrastructure to know that repo and owner we can populate automatically. We don't have to ask the user to type in this information. It's like not necessary. And the same for some of the like what's the API URL of this Git provider. That can all be injected from the context. And then interestingly at the bottom here, secret. We can manage all auth secrets on behalf of your users. So if you run against a public GitHub, if you run against a GHE instance, you can register a command handler and then ask for a repo scope token, which is the one that you need to create a GitHub issue on behalf of the user. So instead of like using our bot, our service account, we can really the bot can use my token that I've provided and use my name to create the issue on GitHub. So really like attribution is a big thing for us. It's really important, especially in this DevOps, and like, you want to keep an audit trail of these things. So these things are important. Was there a question or? No. Sorry. And then ultimately at the end, there's this handle method, which is just like any other good old Spring JVM controller, is where you implement your logic. This is kind of like the function called the utility function that replaces the body with like rewrites the GitHub to Slack identities. And here is the API call. This is like GitHub API, token, API URL, issues create. And that again is an NPM module that I grabbed off the internet, OctoKit, sponsored by GitHub /Microsoft, and kind of creates the issue now. That's all that really is, right? And that you take this, you register this in your automation client, and you spin up this TypeScript project. You spin up this TypeScript application locally. It signs up a let's do this. Let's see what happens when I do it. I just click start here in my IntelliJ, and it does a bunch of things down there. And at the end, it will tell me that it registered with Atomist. It's now kind of listening. This thing has an awful lot of event and command handlers, but it's ultimately listening to this team, which is one of our concepts. It has a Slack team, so you get one, you get a workspace ID, and you put this there and you start it up. It's an ephemeral registration, so it wouldn't do store and forward. So if you disconnected that and someone would invoke the command, it wouldn't really do anything. It's not running in cluster mode, so you don't really get multiple instances that would run this, and a single-threaded node, which is probably not what you want in production. But it's all possible, right? This team, you have multiple teams here. If you split your organization into multiple workspaces, you can set this to durable. Then we store events and command invocations until you reconnect, so you don't lose out on these events. And cluster mode is just effectively running the node process in cluster mode, which is probably way too technical for you guys. But just keep in mind you have like multiple threads, multiple processes here running, so you don't end up with like just one node process. And then you can bring up multiple of these clients. You can use Kubernetes to have multiple replicas, and so on and so forth. And that's all you need. Like you register this, you spin it up, and it's ultimately immediately available in your Slack team, in your API, on your dashboard. One of the last things that I wanted to show you today is I spoke a little bit about Sentry and how we can bring back this information. And we spoke about deployments and how all these things correlate. And I have one more thing that I want to show. So let me go to actually clone this repository and make a couple of changes. So what I now want to do is I want to make it better. And in fact, I will break it, which is usually what happens when I touch code. So git clone. CD07. I'm bringing up Visual Studio Code, and let's make this a bit bigger. I just now want to change my controller and start making this a real Spring Boot application. So what you would do is you would probably put a business layer in there. So you would start by private hello service. This is not the usual angle here. And I'm going to be cheating a little bit, so I'm just going to declare this interface here. And now I'm just going to be using this in this method. Service hello. Name.
The interface as well.
Oh yeah, okay, that's just, yeah, all right. And since I'm a good Java developer, I will disable the test. Because you know what's going to happen, right? I will essentially, when I run this code, when I run the unit test, I will get a null pointer exception. Because I did not initialize, I forgot this auto-wired annotation. I don't have the service implemented yet, so this is just going to fail when I deploy it. But that's the whole purpose of the demo. So let's just run this locally to see if this actually works and not breaks. How do you like the Spring banner? I know that Josh Long, I don't know, have you guys seen Josh Long talk? Like, he gets really excited about the Spring banner. Yeah, he's like, I really like him. All right. What's that? Yeah. Hello service, no, something like that. Git push orange and master. All right, I really advanced my service now. In fact, I could close that issue, and I should have done this with my commit, because then you would have seen how we correlate commits to issues and kind of close the loop in that way. And that really allows us to know which issues made it into your development and into your production environment. So we could tell you, like, because we know what commit made it into this, we can kind of correlate all this information back. And now we'll see this whole pipeline kicking in again. So what I do now is, again, timeout here. I'll show you something else, which is the GraphQL and the way how you can interact with your data. Really take a look at like how that looks. For that, I'll go to app.atomist.com. And I would just log out to make sure that this. So this is kind of actively being worked on. It's the web interface. It shows you like the messages if you can't use Slack. It shows you the messages. It gives you the button. So let me select my workspace here. Atomist Playground. You see that you can reopen issues. Let's do this. And you see how these things update in play. Oh. Yeah, just do this. Didn't want to do that. And so on and so forth. So we see how the goals come in here, how you can follow like the kind of the pipeline in there. And again, we are working on to improve these things. This is also a good place for you to figure out what is actually connected in your team and who's running what. So this shows you all the automation clients that we are running in a particular team. So when you start up your local client, it would immediately show up here. And you could kind of look into like things that are running, and you see kind of like all the, let's pick something. This is our demo SDM, has a couple of command handlers here, and it has a couple of, okay, the scrolling is a bit odd. Has a couple of event handlers with subscriptions, so you can already see like the GraphQL subscription here, and so on and so forth. So it is a way for you to kind of know what's happening in your team, and we're planning to add more information there, like throughput and like logs and all these things. The other really interesting thing is like the whole GraphQL Explorer. So this is like our SQL client, Toad and other things that people use. This is a way for you to kind of like interact with your data, and it really shows the power of the connected graph. So to really show this, let me remove this, because it really comes through when you start typing these things. So I committed something, so there should be a commit with a message, and you get code completion for all of these things. Again, you get all the types that we already have in our core schema, but also if you define your own ingester, your own types that come in from Sentry, that coming from your requirements management tool, all of these things are types, and they show up in the schema in GraphIQL. You can generate JavaScript, TypeScript types for these, not JavaScript, TypeScript types for these things, and use content assist when coding. So it's a really powerful way of looking at your data. So far we just looked at commit, char, and message. That's not really correlation. You get that from any other tool. But let's do something like author. And I get the GitHub login. Again, that's the GitHub payload. Nothing really interesting about this. You see DD-Genome did an awful lot of commit. Atomist bot did some. But, oops. Each author is linked to a person, which is really the real identity here. So when I go in here and I say, give me the name, and then what I really want to do is I want to get to this person's chat identity and his or her screen name. So you see DD-Genome is called David Dooling, and his screen name is David. Now you can put all sorts of constraints on the left. You can do regabs matches. You can say this part of the tree is required, this part of the tree is optional, and so on and so forth. So it gives you a really powerful way of navigating the graph, but at the same time narrowing down the set of data that you want. And again, this really comes in handy when you kind of think about building front ends. Now, this is a query that we're running here. You can take this query, run it manually in your command, in your event handlers, but really what this also is, it's a subscription. So you could take this piece of code and put that into an event handler. So event handlers look very similar to command handlers. There's a different annotation, and you put this GraphQL statement in there, and then every time this matches, this full graph matches, this event handler is being called with this payload that you just defined. And that gives you a really powerful way of like matching on a subset of things in your graph. Again, you can say, I'm not interested in commits that don't resolve to a screen name. Just put a required decorator on these things in GraphQL and so on and so forth. So it's a really powerful way of building up these event-driven systems and decoupling like from these pipelines.
So one thing to ask you, I'm just thinking about this now in my head. You have a very wide range of sources now coming in. I don't know if you're going to get to it in a second. It feels like you could give real insights around the quality of specific projects. So if you took an organization, a big organization with lots of developers in there, you could actually do some very powerful comparisons between
velocity and
and depending on what other sources, if you have SonarQube, LinkedIn, you can really start to. And I'm just thinking about it, like if I had a cyber attack, you could go through the Maven tree. You could actually do. So it feels like you've got two components to it: the automation of the machine, but the biggest piece.
Yeah, you're kind of like unveiling our secret mission here. This is building up the single source of truth of an enterprise, almost like of your development. We're not really going after this right now with our messaging, because we are not the ones building dashboards, but we are like helping enterprises build these dashboards if they really want to get to this information. So we actually have customers that are building like, what's the velocity of this team? Like, where do most of my security violations come from? And this is not to like control your developers. No, it's really about insights. Exactly. We are still a small team, so we're focusing on building out the platform features. And there are many kind of interested parties that will help us and are already helping us building out these adjacent features, right? This is more like a reporting front end that now comes on top of this. Luckily, with GraphQL, many of these things are possible. What did happen here? That looks like a network thing. Let me just press this again. Yeah, so this is strange. It looks like the button press didn't make it to. Come on. Yeah, but yeah, it's a very interesting point. Yeah, that's.
And do you out the box what sort of is it like? It's basically self-consumption, the model, or do you say, is it all open source so people can just start?
There is a SaaS service component to this. This is like the Cortex, the graph, the database that is a SaaS product. Then all the client bindings and all these things that we do are all open source. Okay. So if you wanted to like run queries that aggregate data in a certain way, that's trivial. The API is public. If you sign up with Atomist, you kind of like talk to one of our sales account managers. You're like free to like create whatever dashboards you want on top of that. All right, now this actually seemed to have gone through. I'm now deploying my greatly improved application to production. And again, I was expecting this error here, because this is effectively recreating the same GitHub release, which is not possible, or the same tag now, since I again forgot to rev the version number, which is in other SDMs is actually done automatically, because that's why I keep forgetting that. The internal process that does that, every time we deploy to prod, the patched version number gets automatically revved. Again, some of the automations that we have. We don't have that here. So when I go to this endpoint now, so again, with the SDM, we kind of like set all these CD0, what is it, 7? Yeah, 7. Hello. Yeah, this is what I wanted. This is like the standard Spring Boot error page. It's amazing, I think, but it is what you get. So I effectively broke my application. So now what usually happens, someone gets a ping. So let me see if I got pinged here. Oh yeah, here we go. In my inbox, I got an alert email from Sentry. So usually what I need to do now is, I see this little null pointer here. I click here, I set it to resolved or to investigate. I can also create a GitHub issue or Jira issue right there from this interface. I could link like an issue tracker and whatnot. I could share it. But that's it. I kind of not really, first of all, I left the tool, like the tool that I'm used to. I got an email and I had to click this to get the contextual information. I don't really know where this is running, what commit it is on, who pushed it. So let's take a look back into Slack. What happened here? Guess what? We got a monitoring alert. So again, Sentry is pushing this to us. And one of our policies here is if there is an elevated number of alerts, we just offer to roll back to a version that we know never had alerts, or that we know that is fine. So this is the only production deployment that we previously did. You get like 3 or 4 offered, and now you can actually go in and like, okay, I just want to roll this back. Let's do this. Let's quickly go up here. So these were the goals. Whoop, they all disappeared, and a new kind of pipeline got triggered, and this is like the rollback pipeline. So again, this is now the thing that hopefully running. And in fact, you already see one coming up. One was previously terminated, so one's coming up, but the service actually isn't live. So when we scroll down here, here, we should see now this all going down to 0, the services and the containers. And that's just going to take a little bit of time. Again, this is not us doing this really. This is really using the powers of Kubernetes, but it's us triggering these things based on events that occur along your delivery process. So this is stopped now, and that pod is terminated. So when we go up, we see one started, one running, and there's also the history. It used to be one. There was already one that we terminated. So you kind of keep track of this. Again, a lot more information in the graph. If you needed this to know when it was stopped, why it was stopped, what was the operation stopping it, and so on and so forth. So if all went well, there we go. This is like has successfully rolled back. So again, the thing that really kind of I want to point out here is Atomist is a platform. You can build all these things. You can configure your external systems. And unfortunately, I closed this. Let me bring this back up again. So this Spring demo project, all I did in Sentry was I went in here. I configured the alerts to send us a webhook event. And that URL is what you get from the dashboard when you start up the automation client. It gives you this URL, and then you can put that. And this Sentry alert is actually a typed piece of information. So you created this thing based on like the webhook payload from Sentry, from the doc. So you extracted the pieces that you're interested in, and you correlated this into our graph. And that's really all that needs to be done to kind of expose this information into the Atomist platform. One last thing, usually what people do when they leave this talk is they wonder, how does this relate to, like, where are these builds now running? Like, how did that actually work? So I mentioned the Kubernetes support, and I mentioned that we have 3 namespaces. There's the production and the testing namespace. There's also a third one, which is the SDM namespace. Get pods. And so this is running on GKE somewhere in the US East Coast. There we go. So this is the automation client running on GKE. This is the SDM running that we created for this demo, and you see all these Kubernetes jobs here which have completed. So you can mark a goal as to run in isolation, and what that happens effectively is it schedules itself, the same Docker image, the same automation client, and just executes one goal. So you get like the same Jenkins like semantics around isolation. It just runs as a Kubernetes job and then exits. So we're really using the benefits of like the Kubernetes job scheduler or just resource scheduler here instead of re-implementing these things with other tools. Like Jenkins did this like 10 years ago, but we are really using Kubernetes here. Now, you don't have to use this. You can plug in Jenkins, you can plug in Travis. If you have an investment into these tools, you can certainly don't rip out all these things from day 0. So what we can do with Atomist is we can schedule build pipelines on Travis and then just wait for them to finish and then resume. And so you could do all your important like source code checks, security checks, things if this is a material change or not before you trigger like those sometimes expensive and like long-running processes. So this is possible. So you certainly don't have to go all the way like to running Kubernetes jobs on your own cluster if you don't want to. I think that pretty much concludes what I wanted to show today.